This problem is solved using double distributive method, parentheses x plus 2y, parentheses cubed. You start your problem by expanding the term into 3 separate parentheses. After that, you FOIL your first 2 parentheses to get your first row of terms. After foiling, you should have x squared plus 4yx plus 4y squared times x plus 2y. After that, you rewrite your terms and begin to FOIL with x plus 2y. You multiply x by every term in the first set of parentheses, and then multiply 2y by everything in the parentheses, which would end up giving you x cubed plus 4yx squared plus 4xy squared plus 2yx squared plus 8y squared x plus 8y cubed. After that, you have to identify your like terms. The like terms would be 4yx squared and 2yx squared, and 4xy squared and 8xy squared. Once you've identified your like terms, you can bring them down into what would be your final answer, which you rewrite as x cubed plus 6yx squared plus 12y squared x plus 8y cubed. And now you've finished your problem. Pascal's pyramid. Pascal's pyramid is a simple factoring tree, which starts at 1, then goes to 1, 1, 1, 2, 1, 1, 3, 3, 1, and so on. Right now we're using Pascal's pyramid to solve problem 1, parentheses x plus 2y, parentheses cubed. The cubed, which is 3, stands for the third row of Pascal's pyramid, which would be 1, 3, 3, 1. You write that down spaced apart, so you have plenty of room for your answer. You end up putting your first and second terms in between 1, 3, 3, and 1, followed by 0, 1, 3, 4 from left to right on each term, and from right to left 0, 1, 3, 4 on the second term. After which you solve for each problem or term, which should give you 8y cubed plus 12y squared x plus 6y squared x plus 2x3. After you've written your terms down, you simplify for each, and since there are no like terms in this equation, because Pascal's pyramid gets rid of them in the first step, you just rearrange your problem and you have your answer. Factoring completely. Toast break. Since the first term in your problem is 2, and every term in the problem is divisible by 2, you are allowed to divide your problem in half to make it easier with adding and multiplying. After which you separate your two terms, or your two groups of terms, and then you have to find a common variable in both of them. For the first group, the common variable would be x cubed, since both terms in it have x cubed. And for the second term, it would be negative 27, since negative 54 and negative 27 both share the same term. Both groups would end up equaling x plus 2 or x minus 2. And you would take the two terms that you took out of the groups and put them into their own group. So it would be x cubed minus 27 times x plus 2. After which, you find out what 27 can be square rooted by, and that would be 3 to the power of 3 times x plus 2. Your problem is nearly complete. All you have to do is group together x plus 3 cubed plus or minus x minus 3 and x plus 2. Once you rewrite the equation, you find the similar terms in each and find the basic square from each term. The answer should give you x plus 2 parentheses x plus 3 parentheses squared x minus 3. After those terms are found, you have your final answer. Synthetic division. For synthetic division, you'll have to set up a small chart where you put your first number, which is f parentheses x, or in this case 2. You fill in the chart with the first number of every term in your equation. Then 2 is multiplied by the first number, and then by the next, and the next, and the next, until one of the numbers adds up to 0. Once you reach 0, all the numbers prior to that are that of your equation, which would be 1, 6, and 9. You bring those down to another equation, as well as the powers of x. It should give you x minus 2, parentheses, 1x squared, or x squared, plus 6x plus 9, all equal to 0. You factor the 9 and the x squared, which would give you x and 3 and 3. You take the x and the 3 and you add them equal to 0, as well as the x minus 2. After you've written both of your problems, you have to get them both equal to 0. You have to add the opposite of the two quantities in the problem, so that way both are equal to 0. These numbers are also known as x-intercepts, which are where the points on your line meet your graph on the x-axis. Your first point is x2, and the second point is x negative 3. The x-intercepts help you find your points on the graph. And that is also your answer. Key graph points. To find the degree, you must first look at the first power, which would be the biggest, and find which exponent it is, which is 3, an odd number. So your degree is odd. And you find that it is positive which is your leading coefficient, making it positive. Next, you must find the graph interpretation. As x approaches negative infinity, then y also approaches negative infinity. As x approaches positive infinity, then y approaches positive infinity. The previous problem's x-intercepts were 2 and -3. To graph them would be 2, 0, and -3, 0. These are your x-intercepts, which help you define points on the graph. The amount of turning points you have are based on the amount of intercepts you have, even if they're on the y-axis. Total for this problem, you have 2 turning points. And that is the answer.